But when I was, if I can please get the presentation on the screen, when I asked about making a presentation to visualization to industrialization, I thought, how do I start that? And I said, well, think about Henry Ford, and he was quoted once, and I said, you know what? If I had asked people what they wanted at that time, what do you guess what they answered? They would have said faster horses, because that was the transportation at the time, and it was changed. And I'm sure that if Steve Jobs would be asked, is kind of when he worked on his next computer, if the people have said it's a faster computer, and not that the kids are running around with an iPhone and don't see the world anymore with their own eyes because they can see it through the iPhone, right? So I think there's a lot of change going on, and if we transfer this to this industry, is certainly this visualization to industrialization, is to apply the geospatial competence to industry workflows, to address and enable other geospatial users to do their job, and that goes by applying it to industrial workflows. So geospatial technology is not longer just a map. It goes more. It's an engine for smart enterprises to drive productivity and decision processes. And we hear a lot of discussion. We had this yesterday also in the advisory board. It's kind of, what do we do? What is geospatial? Is managing data and so forth. And I think it's a lot of competent elements in it. It's on one hand side, it's certainly managing these mass data which are coming to us, but it's also kind of one driver is to basically the consequent integration from a sensor to information. It cannot be seen separately in our opinion, because everyone who is an engineer knows if crap information goes in, crap information comes out. And so you have to make sure that whatever comes in is good enough for what you want to do. And if the information at the beginning is excellent, then you can do more with it. You can do simple things, but you can more accurate things and so forth. So that's one thing which is driving us in Hexagon, and we describe this here in this picture the most. And it's kind of when you want to manage this change on Earth, when we heard about the population are growing, 180,000 people per day moving into cities and so forth. It's tremendous what kind of changes are happening in the cities to create more connectivity there, or the connectivity between the cities. And when you do these plannings, and we heard that also from Amar here, is that then you need to go in a digital world, whether it's a CAD system or a GIS system. You need to understand the reality, which is on the right-hand side here representing this. And this reality, which you look at this, cannot be a virtual reality, because it must be a real reality. It's this design, this what you see, look at this, must be real. And with real, I mean it needs to be accurate and current. Because if it's not accurate, what do you want to do this? Then you cannot place an engineering project on it, and you cannot base decisions on it. If it's accurate but not current, so if it's accurate, so let's say some 5 years ago, what the heck has happened since then, and how can you go forward with this data? So the current challenge which we have in this industry is to create this constant workflow for creating a real reality in a digital world, which means accurately and basically because it's more efficient to basically make it also more affordable. And that's the connectivity between the sensors, so capture the real world, feed that into the CAD design, into the GIS world, where you can make decisions, plan the changes, and then execute the changes. And what we heard also, simply what you don't measure, you cannot manage. And that's not only because we are surveyors, that's in every management course you have, whether you run a company or that's what you need to do. So we are focusing on 4 areas. We heard this about verticals, manufacturing, infrastructure, resources, and safety. One is probably the most furthest away for this audience is the manufacturing space. We're quite heavily involved in this. And I think this infrastructure industry can learn a lot from the manufacturing industry. They were the first who basically applied the digital design to production and verified that. And we heard about inspections in industrial from several companies here. And I think one trend here is seen is that these surveying, or kind of what we say inspection, the surveying in industry is kind of the measurement technology in industrial gets automated as well, because they don't want to stop a production line where they produce 1,000 cars per hour, per day, to basically take it out, inspect, and see whether the production line is not right. There, it brings the surveying into the process, right? It's done by robots. It has multiple imaging and scanning sensors on it to do this. We're quite entrenched in those processes where I think we can learn from that as well. The next step, which comes a bit more closer to us, is kind of when you design these kind of processing plants, right? This is kind of a complex building, we would say, but it's for manufacturing. And you see on the left side, you see a map, and everyone can read it. It's kind of a line with some numbers on it, but not everyone can understand it. And that's where then basically comes is, yeah, we need to go in this workflow. And this is a small example which we have here, where you see an aerial map of a factory, which can be seen over the internet or intranet of a company. You can click on the one or the other location where scanning technology was applied. Then you can basically, and that's integrated now in this CAD world, right? Where you see the 3D view of these scans. So it's not only a panoramic picture, but it's overlaid with the point clouds of a scanner. And what you can do now is can move in this scenery and select points in order to get dimensions, whether you want to replace something, know whether the new part is big enough or not. And the nice thing is you can do this from anywhere. If you design the plant in Switzerland and build it somewhere in South America, you can look on the site here with the designers from here remotely. This is a technology which has evolved over the last, let's say, 10 years, but it's now fully integrated into kind of a design package from Intergraph. This is the Smart Plant Foundation, where you basically now connect the buildings in this world, right? So there's this part, you connect that reality with the design of those parts. So you get now all the details, and when was it purchased, when it has to be surfaced, what dimension it is, when is the next maintenance to replace it, and so forth. And by connecting this kind of reality with the 3D scanning world, which came basically from a surveying side into this industry, you industrialize kind of these applications and make maintenance much more efficient. Good. This is the industry side. On the infrastructure, we know kind of aerial images, mapping is something which we do since 90 years. Zeiss and Wild and all these companies who have worked on this. And the interesting is how these images are now applied to everyone. When I had to explain, let's say 20 years ago, I'm photogrammetrist. Nobody knew what it is. Right, so it's kind of, yeah, well, it's a surveyor with a camera in his hand and make measurements, right? But now it's, you say, well, it's Google, right? It's kind of a Google Earth or something like this. So everybody understands it. It's this visualization of our planet and these different sources, right? You have these professional airborne images, which you can collect entire countries like total Germany, maybe in 6.5 days now with a high resolution image. But you have these other images which more crowdsourcing is kind of, you have these smartphones and you can basically geotag the image and send it to kind of the city of Zurich and say, fix my city, there's a hole in the road, right? This is kind of where then suddenly this overlay of these airborne images, very precise, but is then connected to GIS systems to the place to help those people who maintain cities to basically change the world. And then everybody understands it, because if you go to St. Petersburg, you have my St. Petersburg here and you get guided through the city with geospatial information. So these geospatial images are entered into all our lives, and that's the interesting part and the fascinating, where we basically also as an industry have to learn, it's where it drives to, right? Because it's not. If you take these airborne images, there's a new technology also what we drive to. We are driven here that you can do stereo images and automatically extract 3D buildings out of this, because also the standard Kataster goes to 3D. And what we can do out of aerial images can basically extract this in a second per one building per second. And then when you have these buildings, which are based on the cadastre information, you can basically drag 3D images on it, which you take oblique, and create photorealistic models. And I think thanks to these new technologies, which make this awareness about these technologies much more omnipresent in the industry, it's kind of creates a demand for it. And we cannot leave it only to kind of, let's say, kind of those companies who have 100 millions to spend to map the world on this, but it's also being in the micro world. It's kind of in cities, in countries that they have this technology to apply themselves on the demand when they need. And that's where we try to implement these technologies, which maybe some years ago it was not thinkable that we get this when you fly at the beginning of the year. Maybe next beginning of the year you have those 3D models there, but now you can fly it in a day and then a couple of days later you have it. And it goes down to hours. So the maintenance of this work is not anymore the problem. It's changing the market, changing the processes, changing the business models to create this because there's multi-millions invested in these technologies to go forward. And then you can obviously create 3D city models which go to public and safety, which goes to the energy industry to find the sunny side of the roof because that gives you the solar power of an entire city. These are things which are happening and you can update this quite frequently. Well, it's not only from air. We heard this also. You put the scanners and imaging technology on the on cars. You drive this. Interesting is if you directly connect this into GIS packages. So you basically click on an area on the street, and then you get in the GIS package the 3D world. We found some very interesting applications, which one of our customers is finding billboards along his sites because the billboards are on their property, and then they can get some taxes for that. And the nice thing is, because you have the images, you zoom on these billboards and you find the address of the company or the advertiser it is. And I spoke yesterday to a colleague who said, and basically, but it's most on these things are on the private properties, right? So we cannot find this. And I said, well, do you know this or do you guess that? Because again, if you don't measure it, you will not manage it, right? And there will be certainly parts of advertising on your government property which would be entitle you to go and get some money from that back. Yes, building and construction. This is also relatively a well-established business now. It's machine control in construction places, quite heavily applied to constructing roads. It's not only that you save basically money by doing this because you're faster, but also because you're much more control over what you do in terms of layers on your roads. You reduce maintenance of your work and you reduce material you apply to this. In the past, there were, let's say, on a road of 50 kilometers with 50 machines on it, there were 10 surveyors and basically kind of guiding the machines. And today, every machine is equipped with GPS, totally integrated, and there's one surveyor who basically controls the work. So that's the change in the industry which is continuing to happening. Another area which we are pushing technology forward, had an interesting discussion with Professor Konechny yesterday, who said he used LiDAR in 1971 the first time. LiDAR, I think most of us probably would have heard about airborne LiDAR in general, let's say in the 80s. It's now implemented everywhere. It drives on roads and so forth. But we were pushing the LiDAR underwater now. With bathymetry technology. 30% of the populations are living within the 30 kilometers of the coast. So it's pretty important that we understand kind of how the coastal lines are. If you look at these which are taking out of the air from a LiDAR, it goes down to 60 meters deep at the coastal line. So what would you do with this, right? What you would do with this is you could, when you do plannings for, let's say, green energy with windmills along the coast, you want to see how the terrain is underwater up to 60 meters to understand where you place it better. If you want to take care about the environment, you want to see, you don't place it there where you have a lot of vegetation, you place it there where less vegetation is. So you use it on the one hand side to help the industry find good places, but you help it also on the other side to protect the environment. If you have a long coastline in emerging markets where you don't know where you build your next harbor, with this technology you can fly at the speed of roughly 15,000 FIFA soccer fields in a day to detect your coastline depth within 60 meters. And that gives you good information about those assets. Going further, green energy, solar panels. If somebody would have told me as a surveyor at one point in time, I'm surveying solar panels. One of the challenges, if you have the solar panel fields, you want to know whether they're okay or not. So there are thermal cameras on our little UAVs flying over that, predefined in the geo-referenced and repeatable path, and then delivers to you back a heat map which tells you exactly where you have leaks, and then you can repair and maintain this area to basically get more energy out of this. On the resource side, we have quite heavily invested into solutions for the mining industry. It starts from design packages where you basically design the mine. Everyone who does not, also those who don't know how you start a mine, you drill holes and you find out what is underground. Then you model your mine, and then at the end you basically start executing the mining. When you do the mines, then one of the efficiency driver is if it's steep, these mines, but therefore you have a lot of measurement control in it to make sure that the slopes are stable. And one of the latest applications which we have added to our portfolio there is the collision avoidance systems. We spoke about kind of autonomous cars. This is the protection that these gigantic trucks in mines are not crashing into each other, because what we have GPS in it, we know where they drive, we can build a geofence around them, and we know if they're driving at that speed, they would at a certain point in time hit another car if that continues to drive. And there's a warning system which is a communication, a direct communication between the cars who warn themselves when to stop and not to go forward. So it's a quite complex environment in those areas, has all sorts of geospatial technology in. The last area which I would like to speak about is about the safety. Safety is when we talk about water management, you have a lot of dams, also here in Switzerland, to maintain. There's a lot of measurement technology applied to it. What we do is we have technologies which are not only building the dams in the construction of this, but at the end also monitoring them with sensors. These sensors are then basically connected to our Intergraph software, which has technology to have excellent management technologies, where basically the events are coming together, and based on kind of the training of a dam expert who says at that time, at that thresholds, these parameters are so critical that we have warned, then this information is mobilized out to rescue teams, to all sorts of governmental institutions to basically act upon certain warnings. That's done on dams, it's done in tunnels, in the Gotthard Tunnel. The Intergraph group is basically also managing all the activities from all the sensors, humidity sensors, heat sensors and so forth, to basically control this management of those infrastructure. Critical infrastructure has to be monitored from inside and outside. One of these areas which we have heard is about drones. We believe that drones is one of the technology, one of the platform which goes further. It's still early in this technology for the private, for the, let's say, closer to our market, because there's a lot of restrictions in some places. But when we talk to our customers, we have a lot of different applications where we can apply it. In small areas where you can have kind of a small UAV drone without too much restrictions, but also in kind of military-grade drones where downward links go into our Intergraph software to basically help to get information about critical infrastructure which you have to monitor. I think this was kind of the overview I want to give, where I believe that visualization to industrialization will help to enhance geospatial intelligence in other applications. I hope you found that enjoyable, and thank you very much for your attention.